continue with naming of alkanes. Naming of alkanes. How do we name alkanes? Today we'll be talking about organic chemistry. This is Eureka Online. This is Eureka Online, where we put you through all your science subjects or courses. Where we put you through all your science subjects or courses, such as mathematics, further mathematics, chemistry, physics, biology, statistics, computer science, and every other courses that are related to engineering. Every other courses that are related to engineering. Now, today I'm going to be taking you a topic in chemistry, in organic chemistry, which is naming of organic compound. Naming of organic compound. Look at this question. How do we name it? That's what we'll be discussing as we progress in the study. So, in my last video, I taught you about organic chemistry, the definitions, the types. So today, we are going to continue with naming of alkanes. Naming of alkanes. How do we name alkane? How do we name alkane? And in the last video, I was also able to point you to how we were able to get alkane through hybridization. Hybridization can be defined as the rupturing or joining together of atomic nucleus. Atomic nuclei, yes, atomic nuclei, to form a daughter nuclei. The joining together or the rupturing of atomic nuclei to form a daughter nuclei. So now, and I was able to tell you that alkanes are sp3 hybridized. Alkanes are sp3 hybridized. Alkanes are sp3 hybridized. Okay? So when we want to name alkanes, these are the procedure to follow. These are the procedure to follow. We are going to count. We are going to count one. Count to know the parent name. Count to know the parent name. You count in all directions. You count in straight way. You count in cyclic way. You count in branched way to know the parent name. When after knowing the parent name, number 2, name check the substituents. So you check out for the substituents. Substituents are group or an atom that's able to replace hydrogen. Group or an atom that's able to replace hydrogen in the compound. So that's what we call substituent. Substituent can be halogens. Substituent can be alkene group. Okay? So you check out for substituents. Now, number 3. Name alphabetically. Name alphabetically. After you might have seen the substituent, after you might have known all the substituents, then you check those substituents by their alphabet. So the one that have the least alphabet is, or the one that the alphabet came first, is the one you name first. For example, if we have chlorine and bromine as a substituent, we name chlorine first because chlorine is C and bromine is B. So we name chlorine first before bromine. If you have iodine and bromine we name bromine first, we name bromine first before naming the chlorine, because chlorine is C. By alphabetical we have A, B, C, D up to Z. So chlorine is C and bromine is B. So we name bromine first before naming chlorine. And we have iodine. We have iodine as a substituent and chlorine. We name chlorine first before iodine, because iodine start by I. It starts by I. And going by the alkene groups, the first member of the alkene, what is an alkene group? Alkene group is gotten by removing one hydrogen from the alkanes. Alkene group is gotten by removing one hydrogen from the alkanes. For example, if you remove one hydrogen from methane, we get methane. One hydrogen, when it's removed from methane, we get methane. And if one hydrogen is removed from ethane, we get ethane. So if one hydrogen is removed from propane, we get propane. If one hydrogen is removed from butane, we get butane. So it's all these substituents you check and check their alphabet and name them alphabetically. For example, if we have butane as a substituent and we have methane as a substituent in one structural carbon, that means we are going to name alphabetically. So butane will come before methane, because methane, the alphabet that starts methane is M, and the alphabet that starts butane is B. So we name alphabetically. So that's one thing there. Another thing is we check the position. We check the position, check the position, check the position where those substituents are attached. So you check the position where the substituents are attached. For example, if the methane is attached to position 3 in the carbon chain, then we say it's 3-methane. And sometimes you can have two methyl attached to a carbon. So if the 2-methyl is attached to maybe carbon number 2, we say it's 2,2-di. So we usually use a di for 2, we use tri for 3, we use tetra for 4, penta for 5, or pent for 5. So that is how we name. But don't forget that the parent name will come last. The parent name will come last. So we quickly name one or two, and this naming, this science of naming of ALKANE that I just explained is just the IUPAC naming. IUPAC means International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. IUPAC. 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 International Union. International. I stand for international. U stand for union. P stand for pure. A stand for applied. YC stand for chemistry. Okay, so because since I'm able to tell you that we have what we call IUPAC naming, that means we have other type of naming, which is what we call the trivial naming or the common naming. So the trivial naming or the common naming does not involve checking all the processes that I've already listed before. So for example, if you have this structure, CH3, CH2, CH, Cl, CH2, CH3. So if you want to name it by IUPAC, we have the number of carbon we count 1, 2, 3, 4, 5. The number of carbon here is 5. Then we say we are having pent or pentane. We are having pentane. So you can see in between we have a single bond. So we can have a situation whereby the structure can be double bond. So now when we count 1, 2, 3, 4, 5. We can also count 1, 2, 3 because the position of the substituent is also very, very important. So if we count and if we count from the right and we notice that when we count from the right or left, we notice that the substituent is closer somewhere, then that is where we number from. Like this now, we have 1, 2, 3. The chlorine is position 3. We also have 1, 2, 3. The chlorine is at position 3. So in this kind of situation, we don't need to bother the position of the substituent. So the name of this compound is 3-chloro, and then we have the number of the parent name is pentane. It says pentane, 3-chloropentane. Okay. So another one that we name is this. I have a CH3, CH2, CH3, CH2, CH2. So we have a CH2, CH3. Okay? Looking at this structure, we are going to check and count. So we can count straight. We have 1, 2, 3, 4, 5, 6. Okay? Does not end there. We also count 1, 2, 3, 4, 5, 6, 7. So let me just say I have a 1, 2, 3, 4, 5, 6, 7. So when we counted straight, we have a 6. So this, we can also count this way. 1, 2, 3, 4. 1, 2, 3, 4. So at the end, we check the one that is longest, then we take it as the parent name. So we also count, those are the three ways. We count straight, we count it to come this way, we count it this way, we also take it back this way. So I have a 1, 2, 3, 4, 5, 6, 7. So let's now see which one. When we counted, there's no way. This is a very short structure, so we can't use this, and we can't use this too. Okay, and when we counted this straight is 6. When we counted it to this curved part is 7. So we can't take it straight because when we take it straight is number 6, and when we take it to this curve, we have a number 7. So, but how do we now name it? We can have it from count it from the right to the left. We can also count it from the left to the right. Now, the best way to name this is we can't name it counting from the right. Because why? If we count it from the right, we have 1, 2, 3, 4, 5. We are going to kick out this is the substituent. So we are going to kick it out. So this is substituent now. So if you count it, the substituent is at position 5. But if you take it from the right, from this down, that is 1, 2, 3. The substituent is at position 3. So in this kind of situation, we are going to name it counting it from this down up to the straight chain. So the name of this compound is, we have a 1, 2, 3. The substituent is at position 3. So we say we are having 3 methyl, because the substituent is methyl. 3 methyl, 3 methyl heptane, 3 methyl heptane. That is the name of this compound. So look at it clearly. You can see that we did not later name from here, although they have the same number, counting from the right and taking it from the down. They have the same number. But we are considering the substituent. The substituent is here, which is 3. While if you can take it from the straight from the right, the substituent is 5. And if you take it from the downside, the substituent is 3. So that's why we take it from the ground, from the downside, we call it 3 methyl. So another question, that's a question 3. Question 3. Let's assume we have CH3, CH, CH2, CH3, CH2, CH2, CH, you can have this kind of structure too. You can have this kind of structure. Don't forget that we have 2 types of saturated compound, or even unsaturated. So we have 2 types. We have acyclic and what? We have acyclic and cyclic. So what we are dealing with now is acyclic because it's not in a cyclic form. So look at this. If you want to name this, and acyclic is divided into 2. I said in the former video, acyclic is divided into 2. We have straight chain and branch chain. We have straight chain and branch chain. So straight chain is a chain that has series of methylene group. Methylene group, I told you that methylene group in the first video is CH2. So series of methylene group in between carbon atom are terminated by hydrogen. It has methylene group in between carbon atom and what? Terminated by hydrogen. So when you want to name and you see a straight chain, you have to check. And methylene group is CH2. Methylene equals to CH2. Methylene is CH2. So when you want to name, you are going to check, because this is a straight chain. Let's spread it. Let's spread it. So this is C. I have one hydrogen here, another hydrogen here, another hydrogen here. So I'm done with this. Look at this. I have a C. I have a one hydrogen here. It's supposed to be CH2. This carbon is supposed to carry CH2. So but that means we are having a compound in form of methyl, in form of alkyl group. So this alkyl group has come to replace one of the hydrogen here. So that means we are going to have CH2, CH2. Okay? So that means we have another CH2. I'm done with this. I'm done with this. So CH2, this CH2, let me also spread it. I have a hydrogen, hydrogen. So this I have a hydrogen, hydrogen. This I have a hydrogen, okay, CH3, CH3. So if you have this kind of situation, just know that we must try as much as possible to leave our methyl at the end, so that don't break it in a way that hydrogen will be here. So that means we'll be having, let me spread this too. Let me spread it. So how do we now name this? We can take it from here. Let's take it from here. I have 1, 2. We have a 1, 2, 3, 4, 5, 6. That is where we count it in a straight way. We also have 1, 2, 3, 4, 5, 6, 7. You can see. If you take it this way, don't forget that it's not when you want to count to get the parent chain. Don't only count it straight. You have to count it to check even the curved ones. Look at that. 1, 2, 3, 4, 5, 6, 7. Okay, but when I counted it straight, 1, 2, 3, 4, 5, 6. So you can see. I can also have 1, 2, 3, 4, 5, 6, 7. Okay, I can have like 1, 2, 3, 4, 5, 6, 7. I can have like 1, 2, 3, 4, 5, 6, 7. So it now depends on which one you will prefer. So I would prefer to take it straight like this. I'll take it straight like this. Okay? So take it straight like 1, 2, 3, 4, 5, 6, 7. Take it like 1, 2, 3, 4, 5, 6, 7. So the name of this compound is the parent name is heptane. The parent name is heptane because the highest carbon there, the number of the highest carbon is to the chain is 7, going by the path name. So, but when we count, I have 1, 2, 3, 4, 5, 6, 7. Okay? So as we are counting, we met a methyl group here. So which is our position 2. We can't, don't forget that we kick out this. We didn't touch it. So that is also a substituent, which is also methyl group. This one is also methyl. And then this one is methyl. So any carbon you didn't touch when you are counting, that is a substituent. Just check the number of hydrogen that is attached to it. Is one hydrogen removed, then trace it to alkane, then and name it. So that means I have this carbon is attached to position 5. This carbon is attached to position 2. And both of them are the same methyl. They are the same methyl. So that means I will say I'm having the first methyl attached to position 2. I say 2. We say 2, 5. 2,5. So I have 2 methyl. I will not put that. I will not say di, then methyl, dimethyl, heptane. 2,5 dimethyl heptane. So these are how we name organic compounds. Let me also take you to naming, because this is just a branch chain and a straight chain. We can also name the cyclic compound. We can also name it cyclic compound. Cyclic compound. Naming of cyclic compound of alkanes. So if you want to name cyclic compound, what do? We try as much as possible to check. Our cyclic compound is in this form. This is a cyclic compound, and in this topic we call it cyclo. So this, because we are having a carbon here, another carbon here, another carbon here. So we can say this is a cyclopropane. Because the carbon is 3. So it's cyclopropane. So we can also have this. You can have it in form of square. That means I have a carbon here, another carbon here, another carbon here, another carbon here. So that is 4. So this is a cyclobutane. Just include cyclo, then call the name. So cyclobutane. We can also have this. Okay, so I have a C here, C here, C here, C here, C. So this is a cyclopentane, because the number of carbon is 5. Cyclopentane. You can also have this. Look at it. You see I have carbon here. You count that 1, 2, 3, 4, 5, 6. So this is cyclohexane. Okay? So don't forget that it must be single bond all through. If you see double bond in the cyclic compound, then that means it's no more alkane, but alkanes. So look at this. So I have a C here. So I count 1, 2, 3, 4, 5, 6, 7. So by counting, I have 7 carbon. This is cycloheptane. So this is how we name them. But this cyclic compound can have substituents. The cyclic compound can have substituents. So if they have substituents, how do we name them? When an alkane, a cyclic compound of an alkane have substituent, and is one substituent, we don't number. Numbering is not necessary. For example, look at this. Okay, I have only CH3. So numbering is not necessary. Numbering is not necessary. I'll just say I'm having methyl cyclo. Just count the number of carbon, the number of branches. I have 1, 2, 3, 4, 5. So that's methyl cyclopentane. You can see. So if is only one substituent. You don't need to number. You don't need to number. Okay. So look at this. Look at this. Look at this. Look at this. So you can say we are having cyclobutane. Cyclobutane. Okay? But numbering is necessary. Numbering is necessary when the substituent is now 2 and above. Numbering of cyclic compound